Welcome to the deep dive. Today we're really getting into something called concurrency testing, our mission, to figure out what it is, why it's so important for basically all modern apps, and explore some of the tricky challenges and surprising upsides. Think about this for a second. You ever try buying concert tickets right when they drop?
Oh, yeah. The worst.
Right, and the website just freezes or glitches or something weird happens.
hmm Or your favorite app hangs when everyone tries to post at once.
Exactly, that frustration. That's often a concurrency problem. So this deep dive is all about how developers try to manage that chaos.
And hopefully this will help you understand some of the hidden complexity, behind those apps that usually feel smooth. It's not just about squashing bugs. It's really about making software dependable.
Okay, so given that chaotic picture, websites crashing, apps hanging, what is concurrency testing? Like at its heart, what's it trying to stop? The definition we're looking at calls it a testing technique, specifically for finding defects when lots of users are logged in, or maybe doing the same thing at the exact same time. You might hear it called multi-user testing too, right?
Exactly. Multi-user testing, yeah. And what's really, I think, fascinating here is the core challenge. It's way harder than testing simple sequential programs. And that's mostly because of two big things: non-determinism and synchronization issues.
Non-determinism, synchronization. Okay, unpack those a bit.
Sure. So non-determinism basically means you can't predict the exact order things will happen in. Imagine like trying to perfectly choreograph a huge flash mob,
Okay,
but every dancer starts at a slightly different random moment. It's messy.
right.
And synchronization is the massive headache of making sure they don't, crash into each other, miss their cues, especially when millions of people are hitting refresh all at once.
Wow, okay. That unpredictability, yeah, that sounds like a developer's nightmare. So why does it matter so much then? What kind of like real problems does this testing help find? I'm thinking about, multiple people hitting the same database record or using the same bit of code.
Precisely.
And you hear about deadlocking. What does that actually feel like for a user? Is it just slow?
That's a great point. It's not just technical jargon. A deadlock. It's like two cars stuck nose to nose in a single-lane tunnel.
Ah, okay. Nothing moves.
Nothing moves. The whole system just grinds to a halt for those users. So concurrency testing is absolutely vital for catching and measuring those deadlocks, other kinds of locking issues too, and spotting inefficient single-threaded code.
Yeah.
It makes sure that when, say, 10 people try to buy the last item in stock, the system handles it properly, no data corruption, no frozen screens, hopefully.
Got it.
And beyond just finding those critical bugs, it actually helps in other ways too. It can reduce the amount of effort needed for testing overall
Well,
by letting teams focus on the bits of the code that actually interact concurrently. Plus, its encapsulation value means you can test parts without needing to understand the entire huge program. Ultimately, it really helps in improving the reliability and robustness of these complex systems.
okay, so it sounds incredibly powerful, like a secret weapon for building sturdy apps, but there's always a but, right?
Mhm.
What are the hidden hurdles, the things that make this type of testing notoriously difficult?
Oh, yeah. There are definitely some significant disadvantages, big challenges. For one thing, you often need to test across lots of different platforms, and the tests themselves just have to be more intensive, much more complex to set up and run.
Okay.
A really big issue is that in these concurrent systems, functions often do not return the result immediately.
What does that mean? Like they do the work later?
Sort of. The result might come back through notifications, blocks, callback functions, things like that. It's not a simple ask and receive anymore.
Which makes just checking if it worked correctly much harder, I imagine.
Exactly. Way harder. And then there's debugging. Oh, boy.
The nightmare scenario.
Pretty much. Normally, if a program crashes, a developer looks at the call stack. It's like a breadcrumb trail showing how the code got to the crash point.
Right.
But with concurrency, because things happen sort of side by side or out of order,
Yeah.
that trail, the call stack, it often just isn't helpful. It gets tangled or crucial bits are missing.
So finding the root cause is like finding a needle in a haystack.
A very messy, very complicated haystack.
Yeah.
The sheer number of execution paths can be extremely large, I think exponential growth and complexity. And it's just a fact that concurrent programs have a higher ratio of failure than sequential ones, which makes debugging them.
Well, let's just say it's a real challenge. Okay, wow. So pulling this all together then, what's the bottom line for us using these apps every day? Concurrency testing, it seems, is absolutely essential. It catches those really sneaky bugs that only appear when lots of people are doing things at once, but it comes with huge complexities, massive headaches for the people building the software. It's kind of the unsung hero behind making things not fall apart all the time.
That's a great way to put it. And it leaves us with something interesting for you, the listener, to think about. How much of this hidden complexity running underneath our digital world are we even aware of? And what does that complexity mean for how much we can truly rely on the tools we use constantly? Consider that intricate balancing act developers perform every day, trying to give us smooth multi-user experiences while wrestling with these deep, messy problems like non-determinism and synchronization. It's a constant, fascinating struggle.
City.